All right, so this is lesson 1.1, and our notes are on patterns and expressions. This is somewhat review you'll find as we go from Algebra 1 or even pre-algebra. I like to keep the date on my notes, so today is 1/4/2017. And I like to write the goal for the day at the top. So the goal, it's also written on the board, is to identify and describe patterns, and then also to establish an algebraic expression that would represent those patterns. That's what we'll be able to do by the end. So check, we already did that. These patterns observe, drive a variety of decisions, like we just talked about, made in the world every moment of the day. So patterns can drive major decisions. So we're going to look at some smaller scale scenarios so that we can just wrap our minds around it. Example 1, can you predict how many toothpicks would appear in the 20th picture without drawing all 20 or without filling in the chart for all 20? So let's start by filling in this chart. The different thing about this chart is this process column. We're going to come back to that, but first let's just fill in the output column. We have an input column, which is just the number of the figure that we're looking at. So for figure number 1, you can see over here these straight lines represent toothpicks. So figure number 1, there are 4 toothpicks. The output is 4. Figure number 2, there are how many toothpicks? 8 toothpicks. Figure number 3, how many toothpicks? 12. If we were to draw figure number 4 and figure number 5, could you predict how many toothpicks would be in each of one of those? How many, Taylor? 16 in figure number 4. How many, Tyler? No, Zach.
And the fifth one?
Yes.
20.
20. Okay, so you've seen the pattern. I think we could all see the pattern that's existing there. And how would you describe that pattern then? Do what? Okay, so if I take this input number and multiply it by 4, I can get to the output. Did anybody else see it a different way?
I just said add 4 to the...
Okay, good. So adding 4 to the previous number is how we kind of established going down the final output column. So Faith jumped the gun a little bit. That was my next question, was how do I get from input to output without just having to write them all out? You want to establish something there. So if we just multiply times 4, if we multiply the input times 4, that works on the first one. Works on the second one. Turns out it works on all of them. Nice job. So then the nth one, right? It could be the 7th one, it could be the 10th one, the 20th, or the 100th, n could be any number, right? It's variable. So if we could just write that as an algebraic expression as 4n. So we write the same thing in both columns when we get to that point. And the question asks us then to predict now for the 20th figure how many toothpicks would be in that figure, which now that we have an algebraic expression, it makes it pretty easy. We just multiply the 4 times the 20, and we get 80. Good. Multiplication quizzes. It's called Multiplication Monday. So if you're not fresh on your multiplication facts, we're just going up through 12s, not up through 20s, don't worry. So up through 12 times 12 coming Monday. Just give you a heads up on that. So what is the algebraic expression that describes the number of toothpicks in the nth figure? We just wrote that as 4n. Another example. Now this one's like the ones you'll have on your homework. You'll have to draw your own table. And it's a challenge because your homework will be on Math Excel online. So you actually have to get paper out. And using paper and showing work and keeping that in a folder, keeping that in a notebook, you get to use that in your quiz. Okay, so you can imagine that would be useful when trying to answer similar questions on a quiz. So input, process, and output. Just looking at the previous example, it's not too hard to label those columns. Input being the figure number, so we're, same as the last one, we're just writing down the figure number, and then the output. So for number 1, Ariana, how many squares are there in the first figure? Huh. Okay, I'm going to go with 4. I see how you didn't count the blacked out one, but we're going to pretend, I don't know, just ignore that part. So we'll go with 4. And then for the second one, how many are in the second one? Lists. 6, good. And then how many are in the third one, Andrew? 8. So we could predict then how many are in the fourth one. 10, fifth one, 12, nth one. Okay, process. Let's process. It's like the little pinwheel on your computer screen. How do we get from input straight to output? Well, we know that we were adding 2 each time, right? Adding 2 each time, so maybe 2 plays a role. I want you to just think about what could possibly be a way to get from 1 to 4. That also works to get from 2 to 6. Think about multiplying, adding, you could do multiple different things. Cassidy?
I mean, it might not make sense, but I mean, I put that like 1 you would add 3, and then 2 you would add 4, 3 you would add 5.
Okay.
I mean, that's all I.
We could maybe work with that, but I think that would be a more challenging thing to come up with a consistent formula for. Kyle?
N times 2 plus 2.
N times 2 plus 2. Let's see if that works. So we'll do 2 times our n value and then add 2. So 2 times 1 is 2 plus 2 is 4. That works. 2 times 2 plus 2, so that's 4 plus 2. That works. I think you got it. 2 times 3 plus 2. Nicely done. So it's just n times 2 ultimately plus 2. So 2n plus 2. Nicely done. So it turns out 2 did play a factor in that, right? Going up by 2 each time related to the algebraic expression that gets us from input to output. Next, put things into words. There's a reading comprehension factor in this course, and you'll see that in Math Excel too, some of the questions. You just have to be able to read and put the math understanding into words. So a mathematical quantity is anything that can be measured or counted. The value of the blank is its measure, or the number of items that are counted. The value of the input. And then quantities whose values do not change are called constants. But you could guess the next one. In other situations, the value of a quantity can change. Quantities whose values change or vary are called variable quantities. And now we have a couple graphs you can see coming up. Now, these graphs are literally to take our tables and to put them in a visual format for us. Okay, you can start to see some trends visually. Graphs can be helpful for that. So in this case, we're going to come up with an algebraic expression where we could figure out, okay, what is what would be the output for an input? You notice the axes are labeled input and output. What would be the output associated with an input of 6? Where would that dot land? Just put the dot there and then trace it over to the output axis. So obviously you could just follow that pattern and bam, there it lands. Output would be 7. So we have an input of 1, output of 2. Input of 3, output of 4. Input of 5, output of 6. Okay, so you seeing the pattern here? Anybody want to come up with an expression to represent that? Super complicated. Kyle?
Would be n plus 1.
That's it. N plus 1. Just adding 1. All right, next up, example 4. Now we're putting into some context around the graph. Does anybody remember the field trip that we took at the very beginning of the year, the service project? Hey, where did you go? To serve, yes.
I planted a tree.
Ah, you planted a tree.
I did.
Is it still living? Have you gone to check on it?
It's at the
Awesome.
courthouse.
Oh, that's great. What else did people do on that day where we went out and did our service project? What'd you do?
Cleaned the park.
You cleaned the park?
Yeah.
Oh, how nice. By the apartments or something? No?
I don't know. It was like demonstrating though.
Oh, that one. Okay. Very nice. So we all went out, and there were water bottles, and we had to figure out how many water bottles to buy. This is real life. Things like this actually happen. So if you look at this little graph over here, can you figure out how many water bottles would be needed per person, so that if we took n number of people, we would have enough water bottles? Let's start with 5 students. If 5 students attended, how many water bottles would we need? 10. Right? You could look at for one student needed 2 water bottles. I mean, there's the answer right there, isn't it? So we would need 10 water bottles. And if 20 attended, we would need 40 water bottles. And if n attended, who could give me the expression we could write to represent 2n? Good. It's algebra. You're doing it. It's good. Okay, example 5. Complete the table below. So this one it takes away our process column, so now we just have to, sometimes I just kind of like write my scrap work, my process column to the side to try and make sense of things. So going down the output column here, 5 to 9, 9 to 13, 13 to 17, do you notice a pattern there? What's it going up by? Each time it's going up by 4, right? So we could, then for 5, if we have an input of 5, what would the output be for that one? 21. Now we have to figure out a way to get from input to output, and like we had on the front where 2 was involved, maybe 4 would be involved in this one. So try and think of a way to get from 1 to 5, from 2 to 9. Okay, ready? Who's got it? Allie.
Is it n times 4 plus 1?
Let's try it. N times 4 plus 1. Okay, so 4 times 1 plus 1 will be 5. 2 times 4 plus 1. So 2 times 4, let's write this down. 2 times 4 plus 1, 8. That'd be 9. And then 3 times 4 plus 1, that'd be 12. I think you got it. Nice job. So then, algebraically, we could write that as 4 times n plus 1. All right, we're gonna, for part B, we're gonna skip the drawing part. You can draw them if you like that part, but we're gonna draw the next 2 figures. We're just going to copy and complete the table and then figure out the nth figure algebraic expression. So go ahead and try that out on your own.